Okay, tonight we're looking at some more relationships that we can find in diagrams. So a few review words to get us going. Parallel lines are two lines that will never intersect, like our railroads will never intersect each other. Another one is perpendicular. Okay, so perpendicular lines are very helpful. When we find those little boxes, we know we're dealing with 90 degrees. So it's like another given angle measurement. All right, but a new word possibly for you is a transversal. A transversal is a line that intersects two or more lines. So let's highlight this line right here. Okay, that is our transversal. It is intersecting two or more lines. All right. And what's special about the lines that it's intersecting is that they are parallel. Okay, so if these two lines are parallel, it forms some special relationships. Notice that this intersection at the top, this is an intersection up here, is exactly like this one at the bottom. So the intersections are the same. So let's make a comment here about that. So the intersections are congruent when lines are parallel. It only works if those two lines are parallel, okay? So let's look at some congruency and where we find all those angles. Okay, down here on number 1, it says in each diagram, parallel lines are cut by a transversal. So we have two parallel lines and a transversal. Name the angles that are congruent. So if this is my transversal, do you notice that it forms some obtuse angles and some acute angles? So what are the angles that are congruent with angle 1? Well, is angle 1 an obtuse or is it an acute? Okay, so it is obtuse, so I'm going to highlight all of the other obtuse angles. So 3 is obtuse, 5 is obtuse, and 7 obtuse. Okay, so I know those are all congruent just for that simple fact. Also, 1 and 3 are vertical, bringing back a vocab word from yesterday. So angle 1 is vertical to angle 3. That makes them the same. And then just like the diagram we saw up above, the top intersection is exactly like the bottom intersection. Okay, so for my answer, angle 3 is congruent, angle 5 is congruent, and angle 7 is congruent to angle 1. All right, let's look at 2 angles that are congruent to A. All right, the vertical angle to A is C. And then if I scroll down to the other intersection, G is in the exact same spot as A. We call those corresponding, or you can just say, hey, I'm looking for all my acute angles because A is acute. All right, so in orange I've highlighted all of my acute angles and they are in fact congruent. So down here let's list out angle C, angle E, and angle G. All right, one more time. Let's find congruent angles. This time we're looking at Z. Okay, so angle Z is vertical to angle Y. So I know right off the bat that angle Y is going to be congruent because I know vertical angles are congruent. Now if I cut this intersection and I shift it down, it's going to be exactly the same. They're going to be congruent. So Y is in the same position as T, and T and R are vertical. So angle T and angle R. Notice that all four of those angles are your obtuse angles, okay? So they are all obtuse. So if that's what you want to look for, then that would be fine. And you don't have to worry about any of that vocab. You just know that all the obtuse angles are congruent. Alright, down here towards the bottom we have to do a little bit more work. It says in each diagram parallel lines are cut by a transversal and one angle measurement is given. So we have to find all of the missing angles. So just like above, I can find 4 that are congruent. So my obtuse angle here is 150. So that tells me all of my obtuse angles are 150. This one is obtuse and that is 150. So the question is now, how do I find my acute angle? Well, if I look at that transversal, that's a straight line, right? And I know a special number about straight lines, they add up to 180. So if I take away 150, I find that measurement for my acute angles. So 30 degrees here. This one's vertical, so it's 30 degrees there. This bottom intersection is going to be exactly like the top intersection, so all I have to do is slide up a 30 degrees there and a 30 degrees on the other side as well. There is a way that I could check myself. Each of those intersections is a full circle, right? So if I ever want to check my answer, all I have to do is add them all up. So 150, 150, 30, and 30. That should add up to our 360. And it does. Okay, so that's just a way to check yourself if you're ever unsure about your numbers. Okay, all right, let's look at number 5. Same situation, they only give us one measurement. So what are all of my obtuse angles? So I'm going to highlight all of those in blue, and I know those are all congruent. All my obtuse angles are 135 degrees. Okay. Bah. Okay. Works for me. All right, so now, again, they want us to find that acute angle. So I'm going to do the same thing. I see my transversal forming that straight line, forming that 180 degrees. This time I'm just going to subtract 135. So when I subtract, I'll get my acute angle. So I got 45 degrees for my acute angle. So 45 and all of my missing spots. This one's vertical, and then this intersection is exactly like the other. Those two are vertical. Could I check it again? Sure, I should make sure it adds up to 360 degrees. All right, one more to go. Let's try out some green for our acute angles. All those little tiny angles, what are they going to be? 25 degrees. So this is my parallel lines there, going crazy, and 25 degrees there. My transversal on this one is the one going straight up and down. Okay, there's my transversal. All right, so how do I find my big obtuse angle? My big obtuse angle is going to be 180 minus 25. So I'm subtracting and I get an obtuse angle measurement. So that's always a good sign. And now I'm going to come over here and fill in the same measurement. So 155. And up here, this intersection is going to be the exact same numbers. So I don't have to do any more subtracting. Okay, feel free to check it. Make sure the whole intersection is making that 360.